Emily and I made a shake table tower to test if it could survive different earthquake strengths. My partner and I were very excited to start building once Mr. Claus had announced it to us. Our shake table tower was inspired by Amelia's building sketch made in the app Sketch. The sketch was our inspiration to have several supports included in our tower. Each level had a height of 18 centimeters and the total height was 36 centimeters. These are the anchor bolts that keep the tower from lifting. First, Mr. Clausette drilled 4 holes in the corners of the cardboard. Next, we taped half of it to the standing straws. Then, we put the other end through the hole, then taped it to the bottom of the tower. Amelia and I tried to focus on strengthening and support for the bottom level of our tower. We put tape on each edge of the frame so the tower would stay stationary. The second level of our tower was a little bit less supporting than the first level, but we put crossbars in the open squared walls so it could still be useful. On the third level, there are straws sticking out of the corners. These are the stands for the roof. To make our tower unique, we put little flowers on the slanted roof, then put a little flag in the middle saying on one side, "The Man," with quotations, and on the other side, #TheMan. Amelia and I measured our shake table tower and we got the measurement of 68 centimeters. You might notice that our tower looks nothing like our sketch, but that's because the sketch was more of an inspiration than an exact diagram. Static testing was a little test to see if your tower could stay strong with the sandbags on each level. Amelia and I stayed strong the whole time, but if it failed, you wouldn't be able to get any new straws. For strengthening, we had to make strong corners in the tower. We did this so the corners wouldn't bend and affect the whole tower. One of the strongest parts of our tower were the cross braces, because if we used straight lines, the straws would bend automatically. Then the other strong parts were the joints of the tower, because if the joints weren't thick and strong, the tower wouldn't last very long in the testing. The weakest part of the building was the roof because it didn't have any cross braces. Also, the 4 stands were bendy and weak. My partner and I definitely used a lot of tape. Tape was used more often in the joints of the tower because it held all of the important and strong pieces together tightly. Paper was our only extra supply. This was there as a platform for the sandbags for static testing. Here is our shake table tower's first shaking test with 4 100-gram bags attached to it.
Light duty earthquake. Testing 2 and 2. 4.
In this video, you will see our tower collapse with 17 sandbags attached to it. That's 1,700 grams. In this XYZ graph, each color stands for something. First, the blue row measures the bouncing movement of the tower. Second, the orange row measures the forward and backwards movement. Last, the green row measures the side-to-side movement. Our tower held 16 bags. That's about 1,600 grams. It took 7 attempts until our tower collapsed. We were very surprised about how it stood, though. Our tower filled in the point of the crossbars where the 2 straws met. We did not have enough tape and we bent the straw too many times, so that made the tower a lot weaker. So we needed more tape. We needed to be more careful when we were making the tower because we kept bending them. And I also noticed that when the tower was shaking, it kept bouncing off the cardboard. So that made it collapse even easier. So we I learned that we have to be smart with limited supplies. You only have to put the strengthening in the places that actually need strengthening. And you can be very creative when you decorate your tower. So that was really fun. I liked that we got to be collaborative and work with our friends to build this wonderful tower, and we got to have the experience of an architect. We got to be very creative, and we got to have the perspective of a builder of earthquake-proof buildings.
Our tower held approximately 16 sandbags before it fell. I think our tower failed because our X joints weren't strong enough and they couldn't keep up with the vertical joints that were already bending. Our tower snapped from the bottom and the tower collapsed. If Tirel and I had made the cross joints a bit stronger, our tower would have been much more stronger. The cross joints would have held up the vertical joints longer, and then we could have added more sandbags. The building codes help your tower actually, because when we put in our foundation bolts, which were required, they actually helped the tower keep to the base longer. And so the foundation bolts really helped because they kept the tower down while it was shaking, and it actually helped the tower to stay up before it collapsed. I think this project was really fun because we got to see a builder's perspective and all the building codes and things that they have to learn and apply to the building before they just make a building. It's so much more complicated than just adding a few straws and tape. You really have to think about what skills you're going to use and what technique you think will be best for your tower.